Hello students, this is lecture 15 and today we will solve some examples on sampling distribution. So let's start. Let's take first example. Let x1 and x2 be two independent normal 0 1 variates. Right, x1 and x2 and x2 be in two independent normal 0 1 variates. And obtain the distribution of or show that y1 is equals to x1 plus x2 bracket square divided by 2 and y2 equals to x1 minus x2 bracket square divided by 2 are independent chi-square variates. Independent chi-square variates with 1 degrees of freedom each. 1 degree. Let's see the solution. Very simple. What is the definition of chi-square? If xi's are standard normal, then its square is chi-square distribution. So here it is x1 is normal 0 1. x2 also normal. You have to find out the distribution of x1 plus x2 bracket square. So that first of all find out x1 plus x2 probability distribution. Additive property x1 plus x2 follows normal. Additive property is if x1 follows normal mu1 sigma 1 square and x2 follows normal mu2 sigma 2 square, then x1 plus x2 follows normal mu1 plus mu2, that is 0, and sigma 1 square plus sigma 2 square. This one. And x1 minus x2 will be normal mu1 minus mu2, that is 0, and sigma 1 square plus sigma 2 square, that is. Now make this standardize. X1 plus x2 minus 0 divided by under root of 2. This follows normal minus x2 minus its expectation 0 divided by standard deviation under root 2. This follows normal 0 comma 1. And standard normal square is chi-square. So if you take the square of this x1 plus x2 bracket square divided by 2 and x1 minus x2 bracket square by 2 follows chi-square with 1 degree. हेच आपल्याला या ठिकाणी प्रूव्ह करायचं होतं. y1 is equal to x1 plus x2 bracket square upon 2 आणि y2 is equal to x1 minus x2 bracket square upon 2 याचं डिस्ट्रीब्युशन I square 1 आपल्याला प्रूव्ह करायचं होतं. That's we have proved. Let's see the next example. Let xi is right x1 x2 up to the IID normal 0 1 variant periods. Obtain the probability distribution of u is equal to x1 square plus x2 square plus x3 square divided by x4 square x square. Okay. Here, since xi follows normal 0, comma 1, chi square plus chi square with, therefore x1 square plus x2 square plus x3 square follows chi square 3 by additive property. X4 square square, its distribution is chi square 3. And here if you observe, this is the ratio of 2 chi square. And we have seen the definition of F distribution. If you divide this chi square varied by its corresponding degrees of freedom, then it will be F. या ठिकाणी न्यूमरेटर काय स्क्वेअर 3 आलेला आहे आणि डिनॉमिनेटर सुद्धा स्क्वेअर 3 आलेला आहे. जर तुम्ही त्याला करस्पॉन्डिंग डिग्रीज ऑफ फ्रीडमने जे वरच्याला न्यूमरेटरला 3 ने डिवाइड केलं, डिनॉमिनेटरला देखील 3 ने डिवाइड केलं, then you will get the F distribution. So U is equals to divided by x4 square plus x5 divided by 3 by definition of F distribution. By definition of this follows F with comma 3. आपल्याला याचं डिस्ट्रीब्युशन काढायचं होतं का? नाही. So this 3 will be get cancelled. Lies square plus x2 square plus F with implies म्हणण्यापेक्षा write it as that is. That's it. This way we have to solve. Let's see the next one. Let's see one example based on MGF. mxt is given 1 minus 2t raised to minus 8. Identify the distribution. And hence obtain mean and variance. Its mean and clearly you can compare this with the MGF of chi-square distribution. If x follows chi-square with n, its MGF is 1 minus 2t raised to minus n upon 2. So compare with the given MGF. So by comparing with given MGF, we get mx of t is 1 minus 2t raised to 8. By comparing, we get n upon 2 is equals to 8. This implies n is 16. Therefore, x follows I square with 16 degrees. Its mean is n, which is equals to 16. Its variance is 2n into 16. Let's see some more examples. Let exercise the IID normal 0 1 find probability of summation xi square less than 65.227. How to solve this? Xi follows normal 0. Summation xi square, let y is equals to summation xi square this follows chi square with 16. Okay, so by making standardization, you can solve this. Take the expectation of y is 60, variance of y n 60 120. Probability of summation xi square is then 65.227. Probability of summation xi square, this is y, and y is chi square 60. Y less than 65.227. This probability of chi square 60 is then this. After standardizing this, will be z less than minus 60 divided by under root of this is probability of z less than is 5.227 divided by square root of 120. Let's do this. Equal to square root of 120. 19 point this 5.227 divided by that 5 point divided by 0.477, that is 0.48 approximately. This is probability of Z less than 0.47. Now how to see this this is the this is standard normal. त्या ठिकाणी तुम्हाला काय स्क्वेअरची प्रोबॅबिलिटी कशी पाहिजे ते सांगायचं. No problem. We will take one more example, another example for that. This probability is very simple. Z less than standard normal distribution 0.47 is somewhere here. Is nothing but 1 minus probability of Z 0.4. As because for standard normal distribution also probabilities are available from greater than 0. एवढ्या इथून पुढच्या व्हॅल्यूसाठीचे probabilities अवेलेबल आहेत. ठीक आहे. ही probability स्टॅटिस्टिकल टेबलमध्ये कशी बघायची? नॉर्मल साठी बघा 0.47. 0.4 is this and 7. which are corresponding value 31918 0.31918. Solve करा. Solving you will get the okay. मग हे रेग्युलर एक्झाम्पल आणि फिशर अप्रॉक्सिमेशनचं एक्झाम्पल या दोघांमध्ये नेमका काय फरक आहे? फिशर अप्रॉक्सिमेशन केव्हा वापरायचं आणि रेग्युलर एक्झाम्पल केव्हा वापरायचं? फिशर अप्रॉक्सिमेशन ज्या वेळेस एन इफ एन इज व्हेरी लार्ज जनरली काय स्क्वेअरच्या व्हॅल्यू जर तुम्ही ऑब्झर्व केल्या आता या ठिकाणी हा काय स्क्वेअर काय होता 60 आहे. ठीक आहे. स्टॅटिस्टिकल टेबलमध्ये जर ऑब्झर्व केलं तर काय स्क्वेअरच्या व्हॅल्यू ज्या आहेत दिस इज द टी एन इज इक्वल टू 70 पर्यंत अवेलेबल आहे. त्यानंतर मात्र या ठिकाणी पहा फॉर ऑड व्हॅल्यूज ऑफ एन बिटवीन 30 अँड 70 द मीन ऑफ टॅब्युलर व्हॅल्यूज मे बी टेकन फॉर लार्जर व्हॅल्यूज ऑफ एन दिस एक्सप्रेशन ठीक आहे इज यूज. यालाच आपण फिशर अप्रॉक्सिमेशन म्हणतो. फॉर लार्ज एन जनरली एन इज ग्रेटर दॅन 70. ठीक आहे. त्या तसंही आपण एक एक्झाम्पल बघूया फिशर अप्रॉक्सिमेशन. Let's take one example of Fisher approximation. Example number 4. Example 5. If x1, x2, x113 are IID standard normal variates, calculate probability of summation xi square I equals to 1 to 113 less than or equals to 120 8. Now solve the example by additive property. So this problem will be solved by Fisher approximation. Let's see what is given here. I follows normal 0, comma. I starts from 1 to 1, 3. Summation xi square. Let's call it as y. Follows chi square with 1, 1, 3. As just earlier we have discussed, if n is larger, generally greater than 70, then we solve the problem by using Fisher approximation. What is Fisher approximation? Fisher approximation is if y follows chi square with n, then under root of 2y minus under root 2n minus 1 follows normal 0, comma. Consider probability. Summation xi square. We call this as now y less than or equals to 120 is equals to probability of, now make this adjustment, under root 2y less than or equal to under root what we did here, we multiply this quantity by 2 and then we take the square root. So same thing do for here. Multiply this 128 by 2 and take its square root minus under root 2n minus 1 is 113. So 113 into 2 13 गुणिले 2 226 minus 1 which is 225 minus root of 2 to 5. By Fisher approximation, this is under root 2y minus under root 2n minus 1. This is normal 0, 1 which is z. The quantity z unnanar. Less than or equal to 256. Square root is 16. Square root of 2 to 5 is 15. This is probability of z less than or equal to 1. Nothing but 1 minus probability of z. Say this probability will be C, as we have discussed here. I know this probability 0.1. This way we have to solve this problem. Let's see some more examples. Let's see one example of, that is the calculation of probability. Let's solve one example which will be of computation of probability. Let y follows I square 16. Find probability of y less than or equal to 20.465. Probability of 11.152 less than or equal to 26.96. Third is median. Okay. Let's see its solution. Y follows chi-square with 16. First, probability of y less than or equals to 20.46, which is equals to probability of y is what? Chi-square less than or equal to 20.6, and for chi-square distribution the probabilities are this probability is alpha, this point is chi-square n comma alpha. This probability is be calculated as this probability of chi-square n greater than chi-square n comma alpha is equals to alpha. या पद्धतीने ही probability बघितली जाते. म्हणजेच काय ग्रेटर साठी तुम्हाला काय स्क्वेअर ग्रेटर दॅन समथिंग कुठला तरी पॉईंट आहे ती प्रोबॅबिलिटी पाहिजे असेल तर ती स्टॅटिस्टिकल टेबलमध्ये बघितली जाते. ही प्रोबॅबिलिटी कशी बघणार? दिस इज नथिंग बट 1 मायनस root of chi-square 16 greater than or equals to 20.46. And now, how to see this probability? Degrees of freedom 16 and point is 20.465. So let's see here. This is the statistical table, and this is this page is for the chi-square values. This first column is degrees of freedom. Inside values are the points, and the values here at top, these are the probabilities. कुठली probability पाहिजे आपल्याला या ठिकाणी? chi-square 16 greater than 20.465. So let's see this in the 16 degrees of freedom. आणि तो पॉइंट ऑब्झर्व करायचा 20.465. So with respect to 16 and this 20.465, see the value at top. ही वरती व्हॅल्यू पाहिजे. ही जी प्रोबॅबिलिटी आहे इज द आन्सर. काय आन्सर आलं? Probability of chi-square 16 greater than this 20.465 is 0. This way we have to see the. I hope it is clear. Answer is 0. Next one. Probability of 11.152 less than y. Y is chi-square 16, 26.296. Now, how to see this probability? See, suppose this is somewhere 11.152 and this is 26.296. So this is आपल्याला ग्रेटरच्या प्रोबॅबिलिटीज पाहता येत आहेत. तर मग ही मधली प्रोबॅबिलिटी पाहिजे आपल्याला, ही वाली. So this probability will be obtained by this probability minus this probability. This is probability of chi-square 16 then or equals to 11.152 minus probability of chi-square 16 greater than or equals to 26.6. Now solve this. 11.152. 16 corresponding 11.152. Answer is 0.80. Minus 26.296. This is 16. 26.296 is 0.05. So this way I have to see the values. Answer is 0.75. Is correct. The third one is median. How to find the median? Median is nothing but probability of chi-square 16 less than or equals to, or the greater than or equals to median, equals to 0.50. Just see this value from the statistical table. N is equal to 16 च्या corresponding आणि probability 0.50 च्या corresponding आपल्याला पॉईंट पाहिजे. आतापर्यंत आपण काय पाहिलं की N60 आणि पॉईंटच्या corresponding probability पाहिली. आता now we have to see for N and probability we have to find out the point, which is also easy, not difficult. Okay. N equal to 16 आणि probability 0.50 याच्या corresponding बघायचं. 16 okay, this 15.338, median is 15.33 from the statistical. This way we have to find out, we have to calculate the probabilities for chi-square distribution. So we have covered all the different types of examples for chi-square distribution. Let's solve one or two examples. This is example number 6. Let x1 follows x1 and x2 are standard normal variates. Find probability of x1 plus x2 bracket square less than or equal to 0.296, x1 minus x2 bracket square greater than or equals to 5.412. It's its solution. Again, x1, x2 follows normal 0, 1. x1 plus x2 follows normal 0, 2. x1 minus x2 follows normal 0, 2. By standardizing this, x1 plus x2 minus 0 upon root 2 follows normal 0, 1. So its square so x1 plus x2 minus 0 upon under root 2. This follows normal 0, 1 by standardizing. Similarly, this x1 minus x2 upon root 2. This follows normal 0, 1. Take this square x1 plus x2 bracket square upon 2 follows chi-square 1. Same example which I have solved for first one. Upon 2. This follows chi-square with 1. Okay. Now consider the probability. Probability of x1 plus x2 bracket square. Less than or equal to 0.296, comma x1 minus x2 bracket square greater than or equals to 5.412. This is equals to probability of, this is chi-square 1. So divide this by 2. If you divide this by 2, this will be chi-square 1. 0.296 upon 2. Divide this by 2. So this is again chi-square 1. This will be chi-square 1 less than or equal to 0.1 48 into ही probability कशी पाहिजे 1 minus probability of chi square 1 greater than or equals to 0.1, right? Now you can solve this from the, you can see this value from statistic. 1 minus probability of, so students, we have covered all the different types of examples. Some of the problems are also there in exercise. Do there as your own. We have covered uh, as much as possible the different varieties of problems. Pascal distribution. For today, stop here. In the next lecture, we will solve examples of P and F distribution. Thank you.